Hello and welcome to SGN Tech Forum. In this video, I'm going to show you a fundamental of IPSec VPN. We will talk about different high-level overview, and at the same time, we will see a demo. So what is an agenda is why IPSec VPN. So we'll see what IPSec VPN has to offer and why it's so popular. Then component of IPSec VPN, IKE phase 1 and phase 2. So the underlying protocol and their negotiation. Then we will look at the packet walk. So packet walk will help you understand how IPSec decide what traffic to encapsulate and then how to encapsulate. So the decision making process. Then configuration example and analysis. Configuration example may differ from one platform to another platform or one vendor to another vendor, but if you understand the different component and then different phases of negotiation, you can always refer to the configuration guide of that platform and configure your IPSec VPN very confidently. Then we will do some output verification and troubleshooting. So and then it's end of the module. So let's see why IPSec VPN. As you can see on my screen, IPSec VPN can provide you highly secure, authenticated and encrypted site-to-site connectivity. So the initial use case for IPSec was to connect point A to point B. Gradually it evolves as like connecting your branch to the headquarter. So this creates a tunnel which is highly secure, it's authenticated, it's the traffic passing is encrypted, and at the same time you have integrity check. If the packet has been tampered in the middle, then IPSec has that mechanism to detect that and discard that. It can be implemented over any IP enabled network, for example internet, and that is its strength. So since it can be enabled on internet, here is IPSec VPN getting popularity with SDN solution, because solution like connecting to the cloud, or rolling out your SD-WAN infrastructure where you use DIA, direct internet access, heavily to go to your SaaS application, all this done via IPSec tunnel. So IPSec tunnel is now getting more momentum and popularity because it is becoming a fundamental pillar for SDN technologies or cloud technologies. Caveat is IPSec VPN cannot support multicast and MPLS natively, but you can, if you have that requirement, you can definitely use GRE over IPSec and then run your upper layer protocols like multicast, MPLS, and also you can run dynamic routings. The key characteristics or advantage of IPSec is it provides integrity check, authentication, that it authenticate if the both end parties of the endpoints of the tunnel, they are valid or legit, and confidentiality. Think of confidentiality as encryption. So data passing through the tunnel is encrypted. Replay protection, which is duplicate packet detection. So if a hacker sends the same packet again, if he managed to hack it and tamper it and send it again, the duplicate packet detection mechanism is there, and IPSec tunnel is going to discard that. What are the different IPSec component? Obviously cryptographic algorithm, that is your that provides you encryption. Then security protocol. There are multiple couple of security protocol and key management protocols are there, which help build IPSec tunnel. Security association, how the tunnels are built. An IPSec database where it store the security association information and decide what to do with this user traffic, whether to encrypt it or bypass it or send it over IPSec tunnel. Then you have security association and key management. So you don't want your security association to be authenticated once and stay like that. So there is a periodic key you can rotate to keep the security association or tunnel more secure and relevant, right? So there are two phases of IPSec tunnel come up. Basically, think of it the secure communication from point A to point B as two-part process. In first part, or IKE. So there are like IKV standard has evolved since then. We will discuss only IKEv1. There is another standard for IKEv2 also, but I want to keep it simple, and we will build our tunnel using IKEv1. IKEv1 phase 1, the primary objective. So in phase 1, when tunnel comes up, different messages get exchanged, but think of it, phase 1 objective is to authenticate both the endpoints. So in this phase, a tunnel, some parameters get exchanged and they authenticate each other. So it has two mode, main mode and aggressive mode. Main mode, so phase 1 negotiation has two modes, main mode and aggressive mode. Main mode uses 6 message, while aggressive mode uses 3 message, but the goal remains same. That means to authenticate each other. And these, once they authenticate each other, the security association, a logical tunnel is built, and they are bidirectional in nature. Once phase 1 is completed, things move on to phase 2. Phase 2 is your actual deals with your actual traffic. So here you actually determine what type of traffic you want to encrypt. That means what type of traffic you want to secure and send it over the tunnel, and how. Okay, so we define transform set in phase 2. Phase 2 is related with your transform set, and within transform set you can specify your security protocol, the mode, the hashing algorithm, what kind of encryption you want, what kind of compression algorithm you want. So all this you will see in the configuration example. Now in phase 2, to protect your traffic, you have to encapsulate it, right? For that encapsulation, you have two protocols available, authentication header, AH, and ESP. AH only authenticate, provide only authentication, but ESP can do authentication as well as encryption. And ESP is recommended if the security gateway where you are configuring IPSec is doing NAT. So if you have NAT configured on your platform, the ESP is your right protocol of choice for IKEv phase 2. Then ESP, how this tunnel will be built. The ESP tunnel mode is default. So that means any user packet comes, the ESP is going to encapsulate the entire packet, put a new header and send it out. While in there is another mechanism called transport. So in that we only encapsulate the payload, but the header remain intact and we send it out. So tunnel mode is by default mode. Now let's talk about the packet walk. What actually happens when the IPSec tunnels are built, or when you have configured your IPSec tunnel. So the first thing is, let's talk about two scenarios. That outbound, think of outbound as a user traffic is received on inside interface of your firewall. So if the traffic hits the inside and it want to go to a outside domain, IPSec build a SPD, security protocol database, SAD, security association database. So security association database is consulted. So when the traffic hit the inside interface and it matches the crypto ACL, that means this traffic need to be encrypted. Security association database consulted, and it looks that do I have a SA or tunnel built to the end other location? If there is no security association, then the IKE phase 1 and phase 2 starts. So a negotiation happens, and if the negotiation is successful between point A and point B, like in IKE phase 1, we build a bidirectional tunnel. In IKE phase 2, we build a unidirectional tunnel. That means you have to build two tunnels back and forth. Once the tunnel negotiation is done and you have tunnel in place, SAD install that tunnel information in its database and uses that database information to transfer or forward this traffic from which is received at inside interface. It encapsulate it and forward it on the tunnel towards the outside interface. So That's what happened with your outbound traffic. Even if you have tunnel already built, or if you don't have tunnel built. So if the tunnel is already built, then SAD can simply refer to those SA and forward the traffic. If there is no tunnel, then it actually negotiates the tunnel and install that in this database. Now talk about inbound. So if a packet is received on outside interface and it is IPsec protected, so this makes things simple, right? You don't have to match ACL and all. You are just looking at a tunnel packet characteristics, and you know that this is a IPsec encapsulated packet. So what happened again is SAD refers the security association, that how it is linked to which SIP or SAD it should be forwarded, and it consults that and forward it towards the inside interface. Okay, pardon my typo here. So this is about the packet walk. Now, before I dwell into configuration, let me show you what kind of topology we have. So I'm using Cisco Packet Tracer. It's a freeware simulation tool. You can feel free to download it. It's very good, and it take minimal resources. So you can see that I have two ASAs. So we are going to build our IPsec tunnel on ASAs. We have two ASAs. I'm using a switch. So consider this switch as a LAN switch, and then I have a user in form of PCs. Okay, so user, and we are going to build tunnel, IPsec tunnel between ASA 0 and ASA 1. Think about it, like ASA 0 is my home ASA and ASA 1 is my cloud ASA, and that's the tunnel I'm going to build. Okay, so we are going to build a IPsec tunnel between both outside interfaces, and then I will see how my user at this site PC0 can talk to PC1, and the traffic will be encrypted traffic. So that's all I'm going to demo. Now let's go to the configuration, right? Let's analyze the configuration, but think of it that two-part configuration: underlay and overlay. Underlay means that you can reach the outside interface by some kind of routing. Okay, so you have the connectivity. That's why we said that IPsec tunnel can be enabled over IP enabled network. That means you have connectivity towards the other endpoint, right? So underlay configuration is very simple here. I have two interfaces: inside interface, outside interface. Inside interface is using 192.168 1.1/24 network, and outside interface is I have provided a static IP. But if it is a real-time environment, probably you will get an IP address from your service provider, or your depend what kind of circuit you have, right? So you will get a routable IP address. So since this is a lab, I provided a static IP address, and then I have a default route going out of going to the other end, and by configuring this interface VLAN 1, my inside, my outside, and the static route, I have reachability to the next ASA, right? Then what I'm doing, I'm dealing with traffics. So basically object group, TCP UDP, and I'm calling out TCP and UDP type of traffic here. Then I have couple of please ignore this is related to crypto ACL. So then I'm calling couple of ACLs to my inside interface, because inside interface is secure interface, right? The security level is 100. That means without a ACL nothing can go inside. But outside interface security level is 0. So think about security level 0 or outside interface as any router interface. No ACL. If it has IP and you have a route in the route table, it can communicate. Okay, so this is like any typical network interface, but this is an interface where everything is blocked, right? but you obviously want legit traffic to pass inside interface. So for that, I'm poking some holes by using ACL. That's why I said inside access in. And it's nothing that it's very simple. I'm keeping it simple. I'm saying that any TCP UDP traffic which I created using the object group here, service object. So ignore the CLI, just try to understand the concept. So I'm saying that any TCP UDP traffic which get initiated or sources my LAN side going anywhere, allow it. Okay. Then I'm saying that also ICMP I'm enabling, because for lab purpose we need ICMP. I'm saying that any ICMP traffic should be allowed as well. And then finally I say that any IP traffic should be allowed. Also ICMP any I just open it. It's not really secure, but since it's a lab scenario, I said that any ICMP traffic going from inside or coming from outside is allowed. Okay. Then some DSCP configuration, because I have a LAN side, I have a PC connected. So instead of providing an IP address to PC statically, I am saying I am configuring a DSCP on firewall itself. And you can see that I have pool range 192.168.1.5 and I enable the DSCP on inside. Okay. Then access group, and then I apply access group to my inside interface for inbound and outside interface. So that means with this underlay configuration, a very similar configuration on other side, you will have outside to outside reachability between ASAs, and at the same time your LAN side will get IP addresses from the DSCP pool, and you have allowed the traffic, legit traffic. Okay, but these traffic still they can talk to each other, but it's not encrypted, right? So what I have to do to build the IPSec tunnel and send this traffic as an encryption. So that overlay configuration can be broken in like 4 pieces. First, you want to identify what traffic you want to encrypt, or what traffic you want to send over IPSec tunnel, and that is identified by using a access list. Crypto access list. We call it crypto access list. So you can see access list VPN. I named it VPN, and I'm saying that from my LAN to remote LAN, this is the traffic I want to encrypt. But if you have multiple segments in your LAN and you want only one department traffic go as a encrypted, you can choose that. Okay, and keep your access list crypto ACL very limited or minimal. Because why, I'll tell you while we do the verification. So this is the first part, identify the interesting traffic using ACL. Then IKE phase 1. In IKE phase 1, what do you define? You define a policy where you are saying what encryption and what is the method of authentication, how you are authenticating. So you can authenticate using multiple way. You can authenticate other endpoint or authenticate each other using multiple ways, like certificate, a digital signature. But we are using a simplest method where a pre-shared key will be used to authenticate the remote endpoint, and remote endpoint will do the same. So the pre-shared key should be configured on both ends and they should match, right? Then Diffie-Hellman algorithm, I'm using group 2. There are some default things like lifetime and all. We really don't need to configure them, and it will take the default value. So that is your IKE phase 1. Then once the IKE phase 1 tunnel is built, you know that things move on to phase 2, and that's where the transform set comes into picture, right? It tells you how you are going to encapsulate or encrypt the traffic. So you identify the traffic, but then how you are going to secure it, that is a transform set. So here I'm saying that this is my encapsulation encryption mechanism, this is my HMAC. So these values you can provide. Then the crypto map. So in crypto map, so we build the crypto map. In crypto map, first thing what you are going to do is match address, and this is the crypto ACL, what you defined above here, right? So you are saying that within this crypto map, use this ACL. Then you are saying set peer. So this is my remote endpoint where I want to terminate the tunnel or to width I want to build the tunnel. So that is the IP address of the peer. Okay, then I'm calling that this transform set should be used, IKEV transform set and the name of the transform set. So these things will be binded in the crypto map, and then you are saying that crypto map is will be applied on interface outside. But even if you say it is applied on interface outside, in ASA you have to come and say crypto IKEV1 enable outside. Until or unless you say enable and the interface name, the crypto map doesn't come into effect, right? So first thing, you define the user traffic, then you define the phase 1, phase 2, and then you define your crypto map and enable it on the interface. That's it, all you have to do, right? But since we have used authentication as a pre-shared, so somewhere we have to define that key, and that's where I'm defining the key as tunnel IPSec attribute. Okay, so tunnel IPSec attribute is actually go with type IPSec L2L. So you are saying that this tunnel type is going to be IPSec L2L, and then you define your pre-shared key. Similar configuration, exact similar configuration will go on other side. Obviously few things will change, like the peer address is going to change, the IP interesting traffic is going to change because of the change in LAN, and that's all you need to define for your IPSec tunnel to come up, right? Now let's go and validate this on the real demo. Okay, so let me first show you the PC. Start with PC. We are gonna go to IP configuration, and you can see I have set DHCP. That's why my IP has got an IP address from the LAN 192.168.1.5. Sorry if it is not really visible. I can read it for you. And the default gateway is 192.168.1.1, which is the inside interface of my ASA0. Same thing, since DHCP is configured on ASA1 as well, and this NIC is configured for DHCP. It has got IP address of 10.01.10, and the IP default gateway is 10.0.1.1, which is again the inside interface of ASA1. So my PC has got that IP address, and switch wise there is no configuration. I left a default. That means everything is default configuration. Switch mode access, VLAN 1 can travel by default. Now focus our configuration analysis on one of the ASA, and the second ASA just follows, like same opposite configuration. So let me log into the home ASA. Okay, this is, I'm on home ASA. What I'm going to show you is first show version, so you know that the commands are applicable to this version. I am running 8.4, that's my version. Okay, these are the interfaces, and since I have the license, base license, you know that what you can do and what you cannot do, right? The ASA is very license bound. So with base license, you can have maximum limitations with regard to like how many physical interface you can get, how many VLAN you can get, how many inside host you can get. So this is very minimal. So keep in mind, always refer your licensing. That will help you to avoid like troubleshooting situations. Okay, so this, since the license is good for my small network, let me show you the configuration. Okay, configuration you have already seen in the Word doc. So this is my base configuration, inside interface, outside interface, and then ACLs, DHCP configuration, and all those things. So now let's come and do the verification, right? I'm going to first check phase 1 ISACamp ASA. There is no IKEV. So what happened? I mean, I have the crypto configured and everything, and I have enabled it on the outside interface, but still I don't see any tunnel build. So why is that? Because tunnels are tied up with a lifetime. So for a lifetime, so for example, it goes for 5 minutes, up for 5 minutes. Once it is authenticated, lifetime start, and it is up for 5 minutes. After 5 minutes, if there is no interesting traffic, the tunnels are teared down. Okay, so interesting traffic actually uses as an on and off mechanism for IPsec tunnel. So let's create the initiate the interesting traffic. That means you want to ping the other side to create the interesting traffic, and that's what I'm going to do. I'm going to ping the other side because my IP address is 192.168.1.5 and this is 10.0.1.10 is the PC1. Okay, couple of packets, because at this time SAD is starting, and you see I'm started getting reply because there was no tunnel negotiation was happening then. And now let's go back to the ASA configuration. I'm gonna use the same verification command again for phase 1, and you can see I started seeing the output. So IKEP here, that's my other end, and tunnel type is L2L. This is the default role. I am the initiator because I first got the IP address traffic, and state is QM idle. That means phase 1 is authenticated and they can send traffic. Let's check the same thing on other side. Sorry, let me first. Okay, role is same exact information with a flip of IP address. So now IKEP here is the other end, and role is responder because the user traffic was received at other end, and he initiated that point initiated the IPsec negotiation. And state is QM idle. QM idle is a good state. There are multiple states which can actually confuse you. So see the product documentation, or do a little bit of search, and you will see the different stage. I'm not going to dwell into that or dig deep into that. Okay, so our phase 1 is good. Now what we want to do is check the phase 2. So crypto IPsec, let's say. Okay, so I see that I have output within. This is long output. What do you want to see in this? Okay, in this you want to see. Okay, let me bring both back to back here also. Show crypto IPsec SA. All right, so both tunnel endpoint we are going to match back to back and see what we see here. Okay, so on my home ASA, crypto map name is same, sequence number is this, and local address is 200.112. Other side local address is 200.111, which is fine. Permit IP from my LAN side to other LAN side, here from its LAN side to other LAN side, which is actually reverse, right? Then you have local identification and remote identification, their own IP addresses, LAN side. This is also flipped. And current peer, it says that my current peer is ASA1, and this guy says my current peer is ASA2, which is good. What you want to see is packet in caps, packet encrypt, packet decrypt. So these many packets, they were encapsulated and encrypted. That means secure and authenticated, right? Okay. Then what you want to see is in this current outbound SPI is 523 and current inbound SPI is again 523, but yeah, let's see, 77 and 2B. So you look at this, current outbound is 92B, and in this side current inbound is 92B. So one side outbound matches with another side inbound, right? So the same thing, right? Outbound to inbound, the reverse mapping. That's how the SAD database is built. Okay, so this is inbound ESP SAS, so security association, the tunnel which is built actually. Okay, so SPI, now we are talking about both this outbound and inbound SPIs. These are the tunnel information saved into security association database of the gateway where you configure your IPsec router, and this information is actually flipped and they matches with each other, just the direction get changed. All right, so this is the 2 commands, very helpful command you want to use. What else you can check? IPSec SA, IPSec SA. And if you are doing a key management, my pub key, all those key information also you can see, right? So this is ASA 5505. Unfortunately, this is a simulation, so I cannot run any debugs and all, but I think the output analysis what we did is going to help you, and how we break down the configuration and we run over the fundamental is definitely help you and make you a very confident when you are dealing with IPSec tunnels, because this IPSec technology is going to get more and more used because we always want to connect our network to the outside world and via internet securely. So I think you found it useful. Thank you very much for watching. Thank you.